This is lesson 10.1, area of parallelograms and triangles. This is the beginning of our chapter 10, which we discuss. We'll be covering area of different geometric shapes. The first shape we're going to look at is a rectangle. This can be used for a square, but the formula will be the same. It is the area of the base times the height. Now, because you're multiplying, it doesn't matter which one is the base, which one's the height. It all depends on the orientation of the shape. The second one, the area of the parallelogram is the product of the base and the corresponding height. So the same formula for two different shapes, the rectangle, parallelogram, also can be used for the square. Now we use the base and the height. The height is the distance between your bases. Remember, our bases are going to be parallel to each other, so it's the difference between the parallel sides. The base and the height, the way you can always recognize them is by they're always perpendicular to one another. Like in this case here, the base is the bottom part here, the height is the dotted line here, and it's perpendicular to the base. So the base of a parallelogram can be any one of its sides, because you have a choice of this being a base or this being a base. These bases are parallel, so either side based on how it's rotated. The altitude is a segment of the perpendicular line containing the base drawn from the side opposite the base. The height is the length of the altitude. So this is if this is our base for this is our height. If we rotate this around and this becomes our base, then this becomes our height. The height, we had to extend the base out to make sure we got our height here. So let's take a look at a couple examples here. In part A, we are asked to find the area of each parallelogram. So we know the area is equal to base times height. Base, in this case, is going to be 5. It's one side here. Now, the reason we identify this as my base and not the 4.5, because the 4.5 could be the base if you turned this on side, but because the height is the dotted line here, it is perpendicular to this side, therefore this is your base and this is your height. So the area will equal 5 times 4, which gives us 20, and because these are inches, it becomes inches squared. Our units are squared in area. So let's take a look at the second one here. Now, be careful, because the base here can be any side length, and the base is always a side of your shape. Whether it's a parallelogram or rectangle, it's going to be one of the sides. So if this is a side here, this base would be 2 for a height of 3.5. Okay, so once again, I want you guys to get in the habit of writing down, identifying your variables. Write your formula. Now base is going to be 2, height is going to be 3.5. Now 4.6 can be a base, but we do not have a distance between these two parallel sides, so therefore we do not have the height. 3.5 is the distance from this base to this base. So plug our numbers in. Area is equal to 2 times 3.5, and that's going to give us 7 centimeters squared. Alright, so let's take a look at the next example. This problem seems to get a lot of people issues because you have to identify a missing height. And we have a different height over here. So if you look at this problem here, we're trying to find the length of DE, okay, which is going to be our height right here. Now, once again, our formula, it's a parallelogram, is base times height. It tells us the parallelogram here. So our base is going to be 9.4. The height for the base of 9.4 is going to be h. That's what we're looking for. That's our height. That's DE. Okay, so we can't solve it. We have two unknowns. We don't know the area. We don't know the height, the DE. So if we look at it this way, they give us another height, or base. Base is 13 inches. So for the other one, our base can be 13 inches. And for that base, the height, corresponding height, would be 9 inches, because it's the distance between CB and 13 inches. Okay, so therefore this height is going to be 9. So now we can actually find the area of this, which is what we're going to use to find our missing height. So area is going to be equal to 13 times 9. And 13 times 9 is going to be 117. So the area of this is 117. Now, what you need to recognize is that the areas for this shape is the same for both of these equations. It hasn't changed. Just because we use a different base doesn't mean the area has changed. It's just the way we look at it. So if we can take this area and substitute it over for this area, we can find our missing height. So we're going to write our equation area is equal to 9.4 times h. Well, if the area is 117, we're going to plug it in. 117 is equal to 9.4 times h. Divide by 9.4. And h is going to be then equal to approximately 12.4. So the height is equal to 12.4 inches. All right, so let's look at the next one. In parallelogram ABCD, AE is 12, AB is 9, CB is 10. What is DF to the nearest tenth? Which is, DF is the dotted line here, which means it's not one of our side lengths, so it has to be the height. So I want you to pause the video, solve for the height, DF, and then come back and check your work. All right, so let's see how you did. First of all, we set up our two equations for each base. So we have our base and our height. For when our base is 12, our height would be DF. That's our height we're looking for. For a base of 9, our height is 10. So we can use the base and the height of 9 and 10 to find our area, which the area of this parallelogram is going to be 90. We go over here and substitute that in. 90 for our area is equal to 12 times our height. And so 12 divided by 12, and that means our height is 7.5. All right, so take a look at the area of a triangle. Triangle has a couple different formulas. Area is equal to 1/2 base times height, or the base times the height divided by 2. Once again, any side can be a base. The height goes from one vertex across to the base at a right angle. So if it was a right triangle, then your base and your height would be the two legs of the right triangle. Remember to always look for your base is one of your sides. Your height is always that perpendicular line that goes to the base. So let's take a look here at applying this formula. You want to make a triangular cell like the one shown. How many square feet of material do you need if the material is only sold by the square foot? So they give us a dimension here of 12 feet 2 inches and 13 feet 4 inches. So once again, our formula is 1/2 base times height. It's important to write these formulas down each time so that it's easier to memorize. So we have to identify our variables here, our base and our height. Now our base here is going to be the one on the bottom. It's one of our sides. It is 13 feet 4 inches. The height is going to be 12 feet 2 inches. Now, in order to calculate these, we know it's going to be 1/2 the base times the height, but this is not going to be 13.4 or 12.2 because there are 12 inches in a foot, and so it is not base 10, where decimals are in base 10. So the first thing we need to do is we need to convert these to the same unit, or all one unit. And the easiest way to do this is to convert it into inches, the smaller unit. Now, 13 feet 4 inches. Well, 13 feet. How many? We got to find how many inches is that? Well, we're going to multiply by 12. So 13 times 12 plus we're going to add 4 to it because of the 4 inches. That gives us a total of 160 inches. Now we're going to convert 12 feet 2 inches into inches. 12 feet times 12 inches is going to give us 144 plus 2 is 146. So now we have our base and our height all in 1 unit of inches. Take the area equation, 1/2 times 160 times 146. So we'll plug these in our calculator, and that's going to give us the area is equal to 11,680. This would be square inches, because inches times inches gives us square inches. Now the question says how many square feet, so we have to convert this back to feet. So do our unit conversion for feet. We know that 1 foot is to 12 inches. Now 1 square foot means we're going to multiply feet times feet, inches times inches. So 1 square foot is equal to 12 times 12, which is 144 square inches. So we need, this is right here in square inches, we need to convert it into square feet. So we're going to take our number, 11,680 square inches, put it over 1, and we're going to multiply it by our unit conversion. And what we want to do is we want our inches to cancel, so we're going to put the 144 inches squared on the bottom, and it's to 1 square foot on the top. These cancel, which means that we're going to end up with 11,680 over 144, and this is the only unit we have left is square feet. Alright, so let's get at our calculator and check this number. So we're going to take 11,680, we're going to divide it by 144. That gives us 81.1 feet. Now if we're going to make this a material, we always want to make sure we have enough. So in these types of problems, you're always going to round up to the nearest whole number. So we throw out our normal rounding rules out. So 81.1 is now going to make us round up to approximately 82 square feet. That ensures that we have enough to make of our 81.1 square feet. Alright, so converted both units in the same units. It's easier to go from the smaller unit or large unit to a smaller unit. That way you're always working with whole numbers. So let's let you guys try this next one. What is the area of the triangle? Now you can put this in square feet, you can change it to square inches. In fact, let's put this into square inches. So pause the video, work it out, and see what you get. Alright, so let's look here. We got 1/2 base times height. The base is going to be 1 feet, the height is 5 inches. Now if you mix these up, that's okay, because it's a right triangle. It's not going to matter which one you call base and your height. So 1 foot, we got 5 inches. So we're going to convert this all into inches. So we got 12 inches here and 5 inches here. So 1/2 of base times height becomes 1/2 of 12 times 5, 1/2 of 60. And that leaves us with 30 square inches. So if we left this in square inches, this would be our answer. Alright, finding the area of an irregular figure. What is the area of the figure below? Now, irregular shapes. These are shapes that have that we don't have a formula for, but we can break them apart into shapes that we do know formulas for. So in this case here, this looks like we have a square and a triangle. We know how to find the area of both. So the first one, we have the area of the square. Okay. Now the area of the square is going to be side squared, or base times height. We also have the area of the triangle. Triangle is 1/2 base times height. Now the base and the height can be different for each problem. So let's identify our base of our square. It's going to be 6, and it means our height is also 6. For the triangle, we have the base being the same distance here, which is going to be 6, and our height is going to be 8. So now we're going to calculate the area of the square, which is going to be 6 times 6, which gives us 36. Now these are inches, 36 square inches. This one will be area is equal to 1/2 of 6 times 8. So 1/2 of 48, which equals 24. This is also square inches. So now we got both these measurements. We're going to find the area of the total, which is going to be 36 plus 24. So the area of the total is going to be 60 square inches. So anytime you get a problem like this, break it apart into different shapes that you know how to find the area of. That way it simplifies the process. All right, you guys try this one. So what is the area of the figure below? Make sure that you break it apart into two different shapes where you can find the areas of both. Make sure you use the right numbers. Pause the video and check your work when you get done. All right, so let's check our work. In this shape, I started by drawing this line to create a rectangle and a triangle. The rectangle has a base of 60 and a height of 120, which is what we have here. When we come over to the triangle, we're going to have to make some adjustments. The base is going to go from this point here to this point here. It's no longer the entire side. 200 is the entire length, so we have to figure out what is the length from here to here. Well, to do that, we're going to take 200 minus the 60, because this distance goes here to here is 60. So we have to take that off, and that gives us 140. So the new measurement here is going to be 140. Now the height is not the full side here of 120. It is going to be 40 less than that. So we take 120 minus 40. This gives us a height of 80. So now we'll multiply them out. 60 times 120 is 7,200. And 1/2 of 140 times 80 becomes 1/2 and goes into 140 70 times. So we get 70 times 80, which is 5,600. We take our two areas here, add them together, 12,800 square meters. So make sure that when you get irregular shapes, sometimes you may have to draw the figure and then draw to break it up into two different shapes. Now some of you may have tried to draw a line from here all the way down to here and create two triangles here. Only problem is this line does not come down to the very bottom corner. It comes a little bit above, so you cannot make it into two triangles. All right, so let's take a look at our next example. Find the area of the polygon with the given vertices. So first of all, they give us for coordinates, they ask us to make these plots. So we start with the first one. A is 3, 9. So we come over here 3 on the X and go up 9 on the Y. That's our first point, A. B is located at 8 and 9. C is going to be located at 2 and -3. So that's going to be down here at C. And then D is going to be over to the left, -3, -3. So this is going to be C, this is going to be D, and it says, what is the area of the shape that we've drawn? So I'll connect the lines here so we can see a little bit better. These are horizontal lines, so we can just count those. Now, once again, this is a parallelogram, so we have area is equal to base times height. Our base. This is going to be the distance from here to here. So, distance from here all the way to here. We're at 2 over here on this side. We are at -3 over here, so that gives us a total of 5. So our base is going to be 5. Now our height goes from this distance here to this distance here. So we can count the difference in y values, or we can count the spaces. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 spaces up, that means our height is going to be 12. So base and height, area is going to be 5 times 12. Area is going to be 60 square units. Since they don't tell us what the units are here, we'll just say 60 square units, and that's our answer. Now the last example for this lesson involves graphing 3 lines, and then find the area of the triangle enclosed by the lines. So this goes back to what we learned in chapter 3. We first started graphing lines. The first one equation y equals 3/4 x minus 2. Now this is the equation of y equals mx plus b. B is where the line crosses the y-axis, and the m is the slope of the line. So in this case, we have crosses the y-axis at a -2, so we put our dot here. Next, we're going to apply our slope, which means the slope is 3/4, which means I'm going to rise 3, so 1, 2, 3, and I'm going to go over 1, 2, 3, and 4. So now we're going to draw this line here. And that becomes our line. Now, second one is the equation y equals -2. So we got three equations here. We have this equation here, we have this equation here, and we have this equation here. Y equals -2. There's only one variable, which means it's going to be a horizontal line because it says it's y equals. It means it's going to cross the y-axis at -2. So you can come to anywhere on -2 and just draw a line across here that crosses the y-axis at -2. Now the next one here is x equals 4. X means it's going to cross the x-axis at a +4, so I can come here and just draw a line straight down. And this is our line here. So we're looking for this region right here. So what is the measure of this region underneath here? What is that area? Well, it's a triangle, so area is equal to 1/2 base times height. Identify our base and our height. Base is going to be 1, 2, 3, 4 units. Height, 1, 2, 3 units. So, multiply them together and take half. So 1/2 of 4 times 3, which is 12. So 1/2 of 12 gives us an area of 6 square units. Alright, so this completes lesson 10.1.